Hello, I'm Lewis LaGuire, and this is the Unit 15 Screencast. For this final screencast, we'll be looking at some weather in Eagle, Alaska in late January and late March and see the differences that happen due to pressure systems and humidity. Let's first take a look here at January 25th, 2015. We see that there is a very large low pressure system just to the east of Eagle here, designated by a star. A lot of precipitation, although some of it may be light. Over the state, we have a southwesterly wind blowing up through these trough region and two high pressure areas way to the northwest. So we can say Eagle's definitely in a low pressure area. On Thursday, January 29th, we can see that high pressure has come across from Russia, now dominating central and north Alaska. We still have a little bit of precipitation, but the cloud cover is really dissipated at this point, and we have this stationary front, and that's really the only precipitation we can see next to Eagle, although there is a low that's moving up the coast, bringing with it lots of moist air. On the 31st, we can see that all of Alaska is dominated by these three high pressure systems, especially this one here off to the east of Eagle. There's no low pressure systems really next to Alaska at all, and this is causing a lot of heat loss during the night, as the clouds cannot keep the warmth next to the earth. If we hop over to the observations for that day, we can see that the predicted temperatures by the three bars are actually much higher than the actual temperatures that were recorded in Eagle, and this is because of the low cloud cover inherent in high pressure systems, which allow the radiation to bleed off during the long winter nights and actually keep the ground or area cooler for longer periods of time until really another system comes in there and brings with it either some cloud cover or some warmer air itself. If we see the dew point and relative humidity observations for Eagle on those days, 25th, 23rd, 29th, 30th here, we see that's very erratic. That is typical with extremely cold weathers, just really sucking all the humidity out of the atmosphere and setting all the readings off. If we hop over to March 24th in Eagle, we can see that there are two high pressure systems to the east and this trough to the west and north a little bit, south as well, I guess, that is clearing out all the cloud cover in the center part of Alaska here. And this is going to cause pretty cold conditions, but we do also have a low pressure system in the south forcing its way up, bringing moisture. When we skip over to March 26th, we can see that low pressure system has forced a lot of moisture and warmer air into the state. A lot of rainfall along the coast, but more importantly, as far as Eagle goes, there's a lot more cloud cover in that area, and that's really going to help it retain heat. On the 28th of March, we can see that low pressure system continues in the south. It's forcing up moist air over the mountain range here. It's actually, you can see this breakup in cloud cover, and that's some Chinook winds happening, where that moisture is pinned up against the mountains and drops the moisture on the southern side and has dry air on the northern side, and this is assisted with the cloud cover that's in Eagle, really boosting the temperatures of that town. If we hop over to the temperature observations for those days in Eagle, we can see that the temperature trend is a lot warmer than what was predicted through the climatology temperatures here in these three bars, and actually the range of temperatures is not as great as well because the nights are warmer and the days are a little bit warmer. If we took one day back here on the night of the 24th, morning of the 25th, we can see that the range is great compared to the smaller range seen in the next 3 days. If we look at the hourly observations in Eagle for humidity and dew point, we can see a lot more information compared to the last graph. And this is because the temperatures are warmer, able to support more moisture in the air. We can see that the dew point pretty much mirrors the temperature, and that the relative humidity kind of ghosts the temperature, where there's about a 2 to 4, maybe even 6 hour delay on where the temperature spike was compared to the relative humidity. And if we just go up here, we can see that on Tuesday they have this spike here, and then bounce back here, and on Tuesday the spike is the same but a little bit. The day and night variations for temperatures in March is more symmetrical than the day and night temperatures in January, and this is due to the amount of sunlight able to heat the land during the day. If we see here that it goes up at noon and trails off afternoon and is colder in the morning. And then if we go back over to January, we can see that it's a little bit more erratic. I mean, there still are spikes at noon, but there's also other ones which can be caused by cloud cover and other things like that. Based on my analysis, if the temperatures are warmer than the climatology guesstimate of what the temperature will be, then it usually does represent cloudy conditions. As we can see here, the cloudiness in March is jolted the temperature average way above what was predicted. But this may not be true in later months, as cloud cover is way more prevalent at keeping the heat in during the spring and winter months. In March here, we can see how the changes in temperature and humidity reflect the change in weather and movement of different air masses. In the beginning of the week, there was a very high pressure system, and you can see that the dew point here dips way down to 5 degrees before coming back up. And when those low pressure systems came in and provided cloud cover, the dew point shoots right back up here and relatively stays even here, and at about 20 degrees Fahrenheit. And this is a pretty significant change from two weather systems. For this next question, we'll use the map and GOES images, and it just asks if the satellite imagery is consistent with the measurements of moisture. And if we check the map here, we can see that there's a high pressure over the center of the state, and the infrared shows that there is no real cloud cover there. The visible also shows no real cloud cover in the same region, and the vapor shows that there is little to no cloud cover in that region, and it does show a large system in the south and to the west and the north. So yes, I would say it's consistent. Prevailing winds influence the climate of Eagle by primarily coming from the southwest northward, which is where most of the precipitation into Alaska comes from. And really what it does is it makes it more of a drier place, especially than the coast here. And that's because the winds only come from one direction. They carry moisture, and to get to Eagle they have to pass over mountain ranges, and that really depletes the moisture content of the air before it reaches Eagle. So prevailing winds make Eagle a drier place. The event that gave rise to the very low temperatures in Eagle in January are these three high pressure systems that dominated the state. They cleared out most of all clouds that would carry any moisture or keep heat next to the earth, and really allowed those long nights to absorb a lot of radiation from the sun. What little radiation is being put into that area from the sun, given the sun's angle. and the albedo of the snow. So those all factored into the very low temperatures. If there was a low pressure system that had been able to come in and break these three high pressure systems up, then it actually would have raised the temperature and given the climatology probably its more baseline numbers and would have matched that. In fact, that leads us to March, where there was very high temperatures, and that is exactly what happened there as well. If we can go to 6 here, 4 here. Okay, it began very high, cleared out, a lot of radiation going into space during the night, and then as this low pressure system moves in, it's going to bring with it warmer air, it's going to bring more cloud cover. All that's going to heat the area up and allow that heat to stay next to the Earth, warm the area up. If we skip all the way down here to 28th, so much moisture is actually being forced up here. You can see that this little break here is that Chinook winds, and that's help heating it up. If this low pressure system did not gain any strength, and we're going to go back to the 24th, if it just would have brushed up against here, we may have had the same weather pattern that happened on the 26th, but then it probably would have cleared up again and given us those average and mean temperatures that the climatology reported. Thank you for listening, and have a great summer.